All right then. Now here we're gonna do a continuation of where we left. So now we're gonna jump on case number 2, learn on how to decompose and integrate when you are given a function that looks like this. So now remember, we have already spoke about discussed the case number 1. Now here we have two functions again at the top and at the bottom. They can be multiple functions at the bottom, just like we see over here. Remember, the most important thing is the function at the top supposed to have the lowest degree than the function or functions at the bottom. Okay, so in this case, we can see that we have the function, and then we have our functions again at the bottom, which is the denominator. But now have a look at our denominator. Our denominator are already factorized. They are already presented in a form of vectors. So now these vectors, they also present the functions as well. Now in this case, we can see that the first vector, it is raised to the power of 3. That means we have 3 of these vectors, x plus or minus a. And therefore we have only one vector of x plus or minus b. But the question is, how are we going to decompose a function that looks like this? So now remember, we're going to write our division line and start with the first vector. And then we're going to raise our first vector to the very same degree, which is highest degree. And therefore we're going to remember our vector again, it is a linear function. How do you see? It's just x, right? Meaning at the bottom, at the top, which is the numerator, we're going to write the constant because at the bottom we have a linear function, right? It's a linear function, meaning we're going to have to introduce a constant. But remember, if our function, because remember the degree at the top is supposed to be smallest than the degree at the bottom. So if here we had the quadratic at the bottom, so that means at the top, we're going to have what? A linear. If we have a cubic function here at the top, that means at the top, at the bottom, that means at the top, we're going to have a quadratic. That's just how it goes. So then in this case, okay, you shall find, we're going to introduce our constant, which is a, because we're going to repeat the same function 3 times, but lowering the degree. You can see this is 3, this is 2, this is 1. The degree is most definitely decreasing, but we're repeating the very same function. That means at the top, we're going to have to introduce the very same constant. Okay, not the same constant, but a different constant, which is a, b, and c, right? So now we are done with this vector. Now let's talk about this vector, which is x plus or minus b. Again, it's a linear function as well. So that means at the top, we're going to have to introduce a constant in this case, which is d, because we have already introduced other different constants, right? Right. Now let's go through the questions. Now, example number 3, it says to us decompose the following fraction, right? We need to compose this fraction over here. Now, how are we going to decompose this? We're going to apply all the basics that we have learned, right? I'm going to rewrite it first. So that means we're going to have 2x squared plus 3 divided by x times x subtract 1 to the power of 2. So now how are we going to decompose this? We're going to apply the very same basic that we have learned, right? I'm going to write my division line, and then my denominator is the first vector, which is x, and my x is the linear function, meaning what am I going to introduce at the top? A constant, because I have a linear function. So I'm going to call my constant a. Now I move to the second vector, plus my division line. I have this vector, which is x minus 1 to the power of 2. So I can start with the highest degree or lowest degree. It's up to you. So I'll prefer to start with the highest degree based on the basic that we have just learned, right? So it's a linear function again. It's x minus 1. It's a linear function. So that means I'm going to have to introduce my constant, but I have already introduced a. So that means my new constant will be b. And therefore now I decrease the degree of my vector. I write my division line over there. And therefore here I have x minus 1 to the power of 2. And it's a linear function. I'm going to introduce another constant ab. That means here I'm going to have to introduce constant c. And therefore now we have decomposed it. But we need to determine or figure out the value of a, b, and c. Now from here, this is what we're going to do. We have already formulated the equation, right? This is an equation now. So how are we going to solve for A, B, and C? We're going to have to break down these fractions so that we don't want fractions anymore. We're going to have to eliminate fractions. But how are we going to eliminate these fractions? We don't want top and bottom. So I'm going to multiply this side of the equation by this so that I can get the 1 divided by 2x plus I can get the same thing. So that means I'm going to multiply by this on this side of the equation, and therefore I'm going to have to left I'm going to left with um 2x squared plus 3. So remember what I do on this side of the equation, I'm supposed to do it on the other side of the equation. So I'm going to have to consider this fraction first. X will cancel x, and therefore I'm going to have a multiply by this, which is x subtract 1 to the power of 2. Same applies to this fraction. I'm going to multiply by this. I can see x minus 1 to the power of 2 will cancel x minus 1 to the power of 2. I'm going to left with x multiply by b. That means I'm going to have bx. Same applies to this one. I have x minus 1 to the power of 2, and then there I have x minus 1. Only one factor will cancel one factor. I'm going to have to have another one factor remaining behind in this x. So that means I'm going to have to multiply by c by x and another factor, which is x subtract 1. Right? Now we no longer have a fraction. We just have an equation that looks like this, where we need to solve for a, b, and c. In order for us to solve for a, b, and c, those constants, we're going to have to introduce the value of x. But the question is, how are we going to introduce the value of x? We need to kill some of the constants. In this case, this is what we are going to kill. I'm going to kill the value of a. All right, I'm going to kill constant a, but how am I going to kill it? I have to multiply it by 0 so that it can die out of the equation, right? So that means I'm going to have to let my x to be 1, because I can see that when I substitute my 1 over here, I'm going to have 1 subtract 1, it's going to be 0 to the power of 2, still 0, and 0 multiplied by 8 is going to give me 0. You understand? The same applies to there. C, it is also going to die because I'm going to have 0 over here. So that means first thing, we're going to have to let x to be equals to 1, right? So when we let x to be equals to 1, now what will be the value of other constants? So we're going to have to substitute 1 over here, which is our value of x, plus 3, and therefore here we have constant a, and therefore here it's 1 minus 1 to the power of 2, plus b, we have 1 there, plus c, we have 1 there, we have 1 subtract 1. And therefore on this side, we can see that we're going to get 5, and on this side, it's going to be 0. That will also be 0. That means we're going to have b. So that means b in this case will be equals to 5, meaning the solution is already been determined for constant b. Now, again, I can see that the variable that I can kill, it's b and c, right? The variable that I can kill, it's b and c, but how? If I let my x to be 0, because I can say b multiplied by 0, it's going to die. C multiplied by 0 is going to die, and then I'm going to have a as my other constant actually to solve. So that means, again, I'm going to have to let my x to be equals to 0, right? My x to be equals to 0, and I hope that's clear. X to be equals to 0. So if my x is equals to 0, on this side of the equation, I'm going to substitute 2, 0 to above 2, plus 3 is equals to a 0 subtract 1 to the power of 2, plus b, remember my x is now 0, and then there c, and then there I'm also going to substitute 0, 0 subtract 1. Now I can see that I'm going to have this to the power of 0, it's going to be 0, plus 3 is going to be 3. And on this side, 1 minus a, negative 1 to the power of 2 is positive 1. That means here I'm going to have a, will be 0, and that will be 0. So that means here my value of a will be equal to 3. Now, so if I have the value of b, I have the value of a, I'm left with the value of c. But the question is, how am I going to do that? Now I'm going to substitute any value. So long as I know that I have value of a and b, I can let my x to be 2, since well I started with 0 and 1. So that means in this case, I'm going to let my x to be equals to 2. Now, when my x is equals to 2, what am I going to do? I'm going to have to substitute 2 where I see x, right? So plus 2 is equals to, so here's 3. Remember, now we know the value of a is equals to 3. And then with 0, I'm going to substitute my 2, subtract 1 to the power of 2. Now I know the value of b is positive 5. So that means there I'm going to have positive 5. And then my x is now 2. 2 plus c is what I'm looking for. My x is 2. I have 2, subtract 1. Now on this side of the equation, I'm going to have 2 to the power of 2. Definitely would be 4. 4 multiplied by 2, it's 8. And then 8 plus 3 is going to be 11. So on this side of the equation, I'm going to have 11. And then on this side, 2 minus 1, 2. It's going to be 1. And then here I'm going to have 3. And then this side, it's going to be 10. And therefore, then I'm going to have 2 minus 1. Therefore, that means here I'm going to have 2c. 2c, right? So that means I'm going to say 11 subtract 3 subtract 10, right? How much do we get? We get, I said 11 subtract 3 subtract 10, and I get negative 2. So on this side of the equation, I'm going to get negative 2, and this side is 2c. I divide both sides by c, I mean by 2. My c will be negative 1, right? Therefore, now I'm going to write my decomposed fraction. Therefore, I'm going to say 2x squared plus 3 divided by x subtract 1 to the power of 2 will actually be equals to, what's the value of a? The value of a is 3 over x. What is the value of b? The value of b is a positive 5 over what? It's 5 over x subtract 1 to the power of 2. And then what is the value of c? C is negative 1. So here I'm going to have negative by positive is negative 1 divided by x subtract 1. And therefore now my fraction is decomposed. Okay. All right. Now we jump to example number 4. Okay. And then this is what I want to take note of here. It's actually supposed to be an integral. Okay. We're supposed to have an integral. Evaluate the integral of this fraction dx. Okay. So I'm going to rewrite it. So the integral of 2x squared plus 3 divided by x subtract 1 to the power of 2 dx. So now how are we going to integrate this? Firstly, we need to decompose this fraction, right? But this fraction has already been decomposed on example number 3. So we don't have much of work. So that means we have integral of, when I open my bracket, 3 over x plus what? Let me see, let me go back, plus 5 over x subtract 1 to the power of 2 subtract 1. I remember this one, it's x subtract 1 close bracket dx, because these two things are exact same things, just that here we decompose the fraction and we need to decompose it in order for us to be able to integrate this fraction over there. And therefore, now applying all of the laws that we have learned of integration, I'm gonna have to, let me separate it first. The integral of, okay, let me fix my integral sign. Oh my God, I've erased everything, but it's fine. So remember, we said we have 3, I think, 3 over x plus 5 over x subtract 1 to the power of 2 plus, it's negative there. I made a mistake by erasing everything. So here we have negative 1 over x subtract 1 dx. So now let's try to integrate this. This is the same as that, right? So that means we have the integral of 3 over x dx plus the integral of 5 over x subtract 1 to the power of 2 dx subtract the integral of 1 over x subtract 1 dx. So now I'm going to have to take 3 as my constant out of the integral sign. Here I'm going to have 1 over x dx, and then here I'm going to take it's 5. You don't even have to take 5, okay, but you can take it, it's fine. So I'm going to take 5, then there I'm going to have 1 over x subtract 1 to the power of 2 dx. And then on this side, I'm not going to take anything. You can already integrate this. We know we're going to have to introduce natural log, right? 1 over x subtract 1. We know how to integrate this. So that means here we have negative ln absolute x subtract 1 x bar. I'm not going to introduce constant as yet because I still have these integrals once. So that means let's integrate this. So here we're going to have to introduce ln as well, or natural log x. And then this one, we're going to have to apply that law of antiderivative, because here we are integrating. Remember, this 2 is going at the top, is going to be -2, and therefore we add 1 because we are we are not differentiating, we are not deriving, we are doing antiderivative, right? So you're going to say -2 plus 1 is -1 multiplied by that. It's going to give us -5 ln, not ln, I'm lying. I'm actually lying about that. I take that back. So it's not going to be ln. It's going to be -5 over, remember that -1 is going to go at the top. It's going to be positive exponent now, which is x plus 1 to the power of +1. And therefore here, it is already integrated. So that means we're going to have ln x minus 1. And we introduce constant c because we are dealing with indefinite integrals. And therefore that's how we solve this.